Hey, so my name is John Stultz. I work with Linaro and the Linaro Consumer Group, and this is my talk on AOSP currency. All right, so I know a lot of people are really excited. Finally, we're getting crypto built into AOSP. We're going to do blockchain transactions on Overbinder. It's all going to be just rocket ships to Mars. We're all going to be rich, hurrah! But no, this is a bait and switch. This is not what this talk is going to be about. I don't know if this really upsets you. You can close your browser tab and find another way to destroy the world with your greed. Instead, this talk is actually about keeping current with AOSP. So this is something that's been going on quite a bit. A lot of efforts in Google in trying to keep Android devices updated to the latest version of Android. And so here we have our bug droid flowing through the changes of AOSP past 10, past 11, past 12, and into whatever the future might hold. I'm guessing 13, but we'll see. So Google has spent a ton of effort recently over the last couple of years trying to make it so that it's a lot easier for vendors to update devices in the field that have been shipped to the latest Android or latest security updates. And this is really, really, really critical for the ecosystem. It basically provides security as well as competitiveness against other devices and platforms. Value, because these devices can last longer, and consumer happiness. I myself bought a tablet a couple years ago, and it never once got a security update. This is very disappointing because after the first security bulletin, it was basically something I couldn't trust to use, and so it had to be recycled. So nobody really wants that sort of situation. So I want to give lots of kudos to Google because they've done a lot of great work on this. And I think it's really important. That said, all of the changes that are required in order to support this have made Android a lot more complex. And so this can be a lot to get your head around, especially when you're trying to bring up a new device. And so that's what I want to kind of cover in this talk is kind of what can we do about simplifying the process of shipping new Android hardware with the latest version of Android. Because it still takes a lot of effort to get Android up and running on a new device. There are Android-specific bootloader requirements. There's Android-specific, partitioning schemes that are needed. You have lots of device configuration and SC policy that can be very subtle, and then lots of HALs to implement correctly for the device. And I think the hardest part with all of this is that it changes each year, and so this is not a static thing. Just a couple examples here. We've got the ABoot image format, which is what the boot image format is used. That basically has changed a number of times, very recently to V3 and then again to V4. And this is kind of complicated because this requires a lot of kind of deep bootloader changes in order to support that. Similarly with AB partitioning and rollback that happened a couple of years ago, we had the DTBO partitions so that device tree overlays could be applied. And that's, again, requires bootloader changes. There was the system as root change, and that actually it means different things depending on which version of Android you're on. So it can get very subtle as if you're looking at the documentation. So before version 10, system as root means something slightly different than after. Back in Android 9, they introduced the DTSF stab, and so everybody switched to using that. And then in Android 10, it was gone. So it's just one of those there's constant churn and things that we have to move around. Android Verified Boot had a number of iterations over the years. We've had dynamic partitions and overlays introduced, as well as retrofit configurations. Then virtual AB support was introduced, as well as retrofitted configurations for that. But then there's lots of complexity because you can't retrofit a virtual AB on top of a retrofitted dynamic partitions device. So there's just lots of subtle details in that. Lots of different FSTAB requirements, things like first stage mount that was added, as well as things like metadata encryption for user data. And then just the yearly manifest and product shipping level API levels updates that are required. And then there's other things like kernel changes, like the Ion Legacy to Ion Modern to DMA buff heaps, which I'm partially responsible for, so I'm sorry. Now, some background, from my experience in sort of working with Linaro, is that we've been working on AOSP Devboards. And so these are things like the Hikey 960, and the Dragonboard 845, as well as others. Now, these Devboards aren't, form factor devices. They aren't the shipping devices that have lots of functionality. So they're missing things like fingerprint readers and GPS and secure boot being enabled. Additionally, these boards have some limitations in how much we can change around things like the bootloader. Sometimes we have the ability to change it, but it requires extra steps. Like we have to, get the changes we made signed, which can be a little difficult. But then also there's other things where it's just, we don't want to create a fork from a vendor's bootloader. We'd rather kind of stay close to it. So we don't want to duplicate a lot of effort, implementing bootloader support in for a device when the vendor's already doing that internally. So it has some limitations there. But basically, because of these limitations, both in the hardware functionality as well as the change functionality that we have, there's no real way that we're going to have 100% clean, VTS or CTS run on this, because it is, these are dev boards. These are not finished polished devices. They are primarily used for kernel testing and as well as some prototyping and development. So this isn't too critical that we don't have a clean CTS or VTS run, but I'll talk a little bit more about that later, how it can add some complexity. So our general process with these dev boards is that we get a new dev board and we start bringing it up inside of AOSP. Often this means we are reusing some of our experience with previous dev boards. That does mean that sometimes things like legacy configurations get pulled in. So we aren't really starting from zero. We're kind of starting with a legacy code base sometimes. After it's announced, new AOSP requirements will kind of slowly roll in. Sometimes they are unnoticed, and so we just kind of, don't see those requirements until it's kind of a critical point. After every Android release, there's always a couple of things that are broken, and so we have to kind of hustle to get those fixed up when that Android release gets merged into AOSP. And basically over time, these boards become kind of this mix of kind of half current and half legacy implementations. And so, we do try to stay current, but it's just in an ad hoc way. And so, when a Google developer kind of points out there's a major issue, we try to address that. But it's not something we're able to be 100% on. And part of this is that because, we're a small team. We often have more dev boards than we have developers. And so it's one of those things where it can be really hard to fully keep up, especially when we're trying to be able to do that kernel testing and prototyping on top of these dev boards. And I mean, when you look at it, there are just a ton of HALs. I think right now we're at 66. And again, most of these, I don't know about most of them, but not all of these necessarily apply, especially to a dev board. Things like automotive, for example, those don't usually apply to phones. And then things like the biometrics, maybe we can't support, or NFC, et cetera. And so obviously we aren't having to implement all of these, but we do have to kind of understand what we do and not have to implement. And the harder part too with this is that there are multiple supported versions for all of these different HALs. And so it's not just the 65 HALs. There's, the version 2.1 and 2.3 and 2.4, and so we have to kind of understand those subtleties. And so overall, this ends up, just because it's so much, it kind of leads to imitative development, where, we'll end up looking at what Cuttlefish or other recent Google devices are doing and then try to copy that over. And, one downside is that with the treble and the GSI work, Google devices aren't always on the current kind of AOSP bleeding edge. They, like other vendor devices, don't have to update their HALs in order to move to these newer releases. That's kind of the whole benefit of the generic system image. So there's often fewer reference points for what the latest kind of AOSP implementation or reference point, I guess, would be. And so we have to kind of follow Cuttlefish, or we have to wait for new devices to be released. Additionally, when we look at the code, again, because of treble, these generic system images need to be able to work with multiple versions of HALs. So that means that, the Android 9 GSI, it'll work with the V9 HALs, but the Android 10 GSI has to work with V10 and V9, and then the Android 11 GSI has to deal with V11, V10, and V9 as well. And so that means that when we go and look at the code to try to understand what is supposed to be happening, there's a lot of different code paths because the code has to support multiple versions of these HALs, as well as other configuration setups. We've had a couple of issues that have cropped up recently where we enabled some configs to say, okay, we're going to use like the latest version of one configuration. And we missed another, I guess, config option that was required. And so inside of the code, we'd have these subtle breakages where it was like, when we're tracing what's going on, we're actually tripping into legacy code. And it sort of worked, but it wasn't right. And so it was just, these things are really difficult to debug. So for all of these compatibility layers, it also brings complexity layers that we have to deal with. Now, another aspect I mentioned about that we don't always have clean passing CTS and VTS. Well, the CTS and VTS are really what Android leverages to determine correctness. The test very much is the spec. And this is actually a great thing because no one wants to run through some sort of a document trying to, handle the legalese of saying, okay, yes, the board must and should, and, thou shalt do this. That's, something to leave for lawyers. It's really nice to have a testable framework where we're able to say, okay, we can test the device. If it passes, it's good. If it doesn't, it's bad. And that's really, it's excellent. But there are so many tests in CTS. There's over 1 million tests. And so when you already have a board that you're not expecting everything to pass on, trying to go through and diagnose for each failure what's wrong, it means that we need to kind of go in, look at the test, try to see what it's testing, understand what it's trying to do, try to see if that makes sense on the dev board. And if it does, then try to figure out what we're doing wrong to fix it. And so this just takes a lot of time. So it's one of those things where it's a blessing that we have ZTS and BTS, but I think it's also just difficult for that to be kind of the main validation. Now, one of the issues that we've seen is there's some issues with documentation. I don't want to complain too much here because there is a lot of great documentation on source.android.com. But the coverage of topics is somewhat scattershot. Some things have nice high-level descriptions. Some things have some nice low-level kind of how-tos, but it's not really comprehensive. Additionally, it's not always current. If you look at the main media page, you scroll down to the bottom there, they're telling you about how to implement something, but go look at this Samsung Tuna example, and that was the Nexus 10, which is not even in the tree anymore. And so it's one of those things where I feel like it could use some freshening up in places, especially if you compare it against the Android app documentation at developer.android.com. That seems to be much more coherent and comprehensive. So it's one of those things where I feel like it could be improved. An example that we have is that I recently tried to enable USB webcams on one of the dev boards, and I followed the instructions. They have a really nice how-to. It's kind of just step by step. This was great. The problem is that when I got to the end of it, it didn't work. I had to make additional changes to SC policy that weren't in the documents, as well as some permission issues on the devices that needed to be resolved. And then on top of that, sure, it works sort of because, we can capture pictures. But when I try to record video, it crashes. And so it's one of those, I still have, work to kind of chase down and understand what's going wrong there. And I mean, like any big code base, the source is always the documentation. It's the best documentation, at least, because it's always the latest and greatest. But again, like I mentioned with the GSI, the source has to support multiple versions of HALs. And so it is very difficult to understand sometimes what is the current code path and what is the legacy code path, especially when there's multiple legacy code paths. And so it's just, it's tough to use that as it's hard to figure out what is the way that it's supposed to work often. Additionally, some fairly simple questions are just not documented. If you want to figure out what are the HAL versions that are required for a current device, that isn't actually in the documentation somewhere. You've got to instead go read an XML file, which it's kind of tough. And overall, I'm very sympathetic to this because it's not easy to have great documentation. This is a really hard problem. I've previously been doing kernel development and maintainership, and I know that having really current, up-to-date design and architecture documentation, along with accurate interface descriptions, is really hard, especially when things are constantly changing. So it's one of those things where I'm very sympathetic to how hard this is. Okay, so end of rant. You probably are thinking that, okay, John, you've gone on for quite a while about how you're not very good at doing the job you're supposed to do, and that you'd like somebody to make it easier. And that's maybe a little fair. I will admit I can be an idiot sometimes trying to get some of these implementations, trying to enable things. But I'm also don't think that I'm too unique or special in the way that I'm an idiot. I think there's a lot of folks who have similar troubles trying to figure things out. And so my claim here is that this does, I suspect, matter to the ecosystem. Over the last decade, we've seen a lot of consolidation. If you look at just the Google and Nexus Nexus and Pixel devices, before 2012, they were cycling almost every device between different SoC vendors. But since 2015, it's been a one-stop shop. So it's one of those things where, we're really seeing kind of a consolidation, not a lot of variety in at least those devices. Additionally, if you look at the current Android phone SoCs that are shipping in volume, they're really only about 5 players. And of those 5, the first 2 have something like, upper 70s, 80% market share. And so that's, it seems to be kind of a narrowing field. And so I think we could have a good goal of lowering the cost of developing these Android devices. Because there's a lot of SoC vendors that are still out there, but a lot of them either don't, have the resources or spend the resources working on Android BSPs, at least for phones. Maybe they do automotive or maybe they do TV or something. But if they are doing these efforts to create an Android BSP, it's very likely they're not seeing much return on these efforts, and it's not a trivial thing to do. And so I think it's important that we find a way to kind of lower those barriers to entry. Now, having barriers to entries for new players, for established players, a barrier to entry is sort of a moat. And so, some bigger players may not actually be very eager to see those moats dissipate. But I do think that this is important even for those major SoC players, because I think that any of those big players would rather spend less time doing, bootloader or partition changes or kind of reworking HAL requirements for whatever commodity functionality that is being done that year, and would really rather spend time on the distinguishing features of their IP and being able to kind of provide that differentiation that their unique hardware kind of provides. And so it's one of those things where I think that, making this easier just allows everybody to focus on the more important things. So what can be done here? I kind of was complaining earlier about documentation, so let's try to think about that a little bit. Ideally, we want to have holistic and current documentation. One idea might be is that the source.android.com documentation isn't actually a public project, so maybe that could be made public so that people could submit changes through Garrett or whatever, to be able to kind of crowdsource a little bit of improvement there. Linaro also could try to go through and do document testing, basically audit the documentation. When we bring up a new device, maybe let's just start with the documentation, go step by step where things are missing, provide that feedback. If you actually look in source.android.com, on every page there's this rate and review, and so we could go through and just kind of provide that feedback. Now we'd want to work together with Google to make sure that that feedback wasn't lost in the noise of all the other things going on the internet. But yeah, but this is something maybe would be worth exploring. Another item is it would be really nice just to have a starting point, to basically having a reference build target and HAL library. When you have a new device, often people are just kind of copying over what another Google device has done, which doesn't necessarily make the most sense when you're starting from scratch. So maybe having a real reference implementation that has the latest information for the latest config and device MK settings. It would be nice to even have a reference HAL library, something that would potentially even be able to pass CTS, if that's possible. Now, a lot of this is actually kind of provided by Cuttlefish in many ways. And so, I think that I don't want to really duplicate what Cuttlefish is doing, but Cuttlefish also, it's a virtualization platform, and it's really trying to, it's really kind of a test and validation platform. And so it has to deal with the realities of trying to, emulate all of these different hardware devices that the HALs need. And so it does have to deal with the realities of virtualization and that sort of thing. But maybe we could add in some documentation in the implementations to kind of say, like, here is the chunk that is cuttlefish specific. Replace this with what your device needs here. I don't know. It's one of those things where I think that this is an area we could kind of improve. Additionally, trying to find a way, and this is something Linaro has kind of been beating on for a while, make commodity functionality generic, basically trying to push more of that functionality upstream so that Android really doesn't need hardware-specific HALs. We already have a number of generic HALs in AOSP. Things like the WPA supplicant, BT Linux, the DRM hardware composer, etc. But for most of these, they aren't actually used on shifting devices. So it would be good to work with vendors to figure out, like, well, what's missing here, and how can we extend these or extend the Linux interfaces so that these generic implementations could be used, because I think that would let people focus on other areas that are more important. Finally, we talked about this at length at the last Plumbers Android microconference, but have some sort of an Android, standard bootloader. Basically, push off the ownership of all of this kind of ever-changing requirements for the bootloader onto Google, and say, hey, let's either chain load something or have something like a UEFI app, or I don't know, maybe a library that is really easy for vendors to integrate each year into their bootloader code. And be able to provide whatever those requirements are for that year, because it's really just a waste to have every vendor churning on this stuff every year. So it's one of those things. I think this would be great because it allows vendors to maybe focus on just one implementation of a bootloader per SoC, and so then they could, be able to use that SoC with Chrome OS or Android or classic distros or whatever. So it kind of widens the scope of what they can, do with their SoC. So maybe using something like a standard bootloader, so EBBR or similar, might be useful here. Again, we did cover this at length, so I don't want to cover too much here. You can follow the links and hear more from Sam on this. And so that's it for me. We can have some discussion here, hopefully. Feel free to email me if you have any feedback. I appreciate it. Thank you so much.